In this segment of the training, we're going to be talking about the Laminators drive system. Now, the drive system, just by name, means that it drives the material, so that's what moves the material through the machine. There's going to be two components to that. You've got a mechanical and an electrical motor component. So we're going to break it down into those two parts and talk about what makes it tick. Any drive system begins and ends with the motor. So this is a typical motor on a Orca machine. And that's the machine we're going to start out with first. And one thing to point out here is, or a couple of things. There's going to be a tag on all motors that gives it specifications. And you're going to need to pay attention to that if you when you're setting the speed control. So we'll get to that when we talk about the electric, but this is really where it comes together. You've got the mechanical part, the electrical part, and drive motors in general are very reliable. So usually that's not the problem if you have a drive problem on the machine. One other thing to mention is usually when we talk about laminating machines, as far as laminating professionals, we talk about the drive side and the control side. The drive side is going to be where most of your gear works and chains are, and then the control side is going to be where most of your electronics and electrical components are. It's done that way in lots of industrial machines, and it's really just a matter of the drive side tends to be a little more dirty, and you want to keep your electrical and electronics clean. So this is the drive side of the machine that we talked about, and this is where your motor shaft comes out, and you're going to have a series of chains and sprockets that connect all the necessary parts of the machine. One thing to note is that your drive on the laminator rollers is always going to just be the bottom roller. You'll notice these chains are connected to the bottom, but they're really not connected to the top. So all of your chains and sprockets need to be tightly attached. They're either going to use a bolt that attaches them to the frame, or they're going to use set screws that go in from the sides of the sprockets. So if your sprockets get out of alignment, it could cause you problems with noise and parts breaking. And then also your chains need to be somewhat tight. Now, amateur technicians tend to make chains too tight. These are going to have a little bit of play in them, and that way as the machine functions, it's not getting a lot of resistance from having the chain too tight. This particular machine uses two types of chain tensioners, so it's a good one to start with. You've got a tensioner here that has a bolt that will allow you to change the angle of that idler in order to get the tension on the chain that you want. And then you've got something that's called a Lovejoy. Lovejoy is the customer or the company that makes this device. And what this is really, in the block of it here, it has a rubber block which has a little bit of give to it, and that allows you to tension the chain and still have a little bit of play in it. It's usually used on longer chains because they tend to bounce a little bit more, and this will actually adjust with the moving chain. As far as problems with the drive system, the mechanical part of it generally is going to come from either the chains being too loose or too tight, or some sprocket that is not attached properly or aligned properly with the rest of the drive system. One thing that I have seen quite a few times over the years is on your main drive there is a key. It's just a flat piece of metal that helps the gear stay in the right position, and over time they have a tendency to work out. So the customer will say the machine makes noise but it doesn't go anywhere, and you'll open up this cover and you'll find that key has worked its way out and worked its way loose and dropped into the cabinet. A note about safety here, whenever you're working with this drive system while it's moving, you need to keep your hands clear, and I like to use the foot pedal to energize it so that I have the best control of it. If you use the switch on the control panel, you'd have to get up to turn it off if something went wrong. So I would always use the foot pedal, start at a low speed, and keep your hands clear of any moving parts. This unit also does have a pneumatic clutch, so the mechanical drive on your pull rollers in this case is going to be controlled by an air pressure setting. Now we're going to talk about the electrical component of the drive system. So usually what's going to happen is you're going to either press the foot pedal down or to get drive, or you're going to turn a switch on the control panel. What that's going to do is energize the motor speed control to run at a speed that you have set on the potentiometer. So there's going to be a speed setting. So how that works is with this board right here, and this is a very common board that's used on a lot of different laminators and also just a lot of different industrial machines. It's called a KBIC motor speed control board. And what happens when you step on the foot pedal or press the control switch, it activates this board with line voltage. So in other words, this machine runs on 220. It will apply 220 volts to that motor speed control, and based on where you've got the speed dial set out, it sends a DC signal to the motor. Now I mentioned before that the motor has a tag on it with specs. The most important spec on there is going to be the max voltage. So max voltage, DC voltage, is at the highest speed. On this particular machine, it happens to be 90 volts. So you'll see on your KBIC board, you've got L1 and L2, that's your line voltage coming in, and then you've got A1 and A2, and that's going to be your motor voltage. And so you can use your meter and check the line voltage coming in to make sure you have either 220 or 110 depending on which machine we're talking about. And then you can also check the voltage out to the motor. Now this board has been very reliable over the years. They do go bad, and it's just a matter of checking the inputs and outputs. And you can also check the potentiometer resistance, and that resistance is usually written on the back of the potentiometer. So the heart of the system here is the KBIC speed control board. Now in this video series, there's no way I can tell you how every machine is wired. If you have problems that you think are related to the wiring, you're going to have to get a hold of a wiring diagram for that machine. But I can tell you, if you can't check the motor voltage here, you can also check it usually on the drive side where the motor connects to the machine. And one other thing, the main reason why DC current is used to run the motor is because it's steady. If you use the AC motor on these machines, when the heat kicks on, it causes the motor to speed up and slow down, and we need to be running at a constant pace. The other reason is because DC has polarity, as you know from your basic electricity and electronics. So if we switch the polarity on the motor from positive to negative, it changes the direction of the motor and just makes it run backwards. So if you have a reverse switch on your machine, that's usually all it's doing, is changing the polarity. So here's where I'm talking about. This is where our motor connects on the drive side. So we would be able to check our DC voltage right here if we can't get to it on the control side. The other thing I forgot to mention when I was talking about adjustments are the bolts that hold the motor in place are usually slotted so that you can move that motor up and down to get the slack out of your chain. And that's usually what I would call the coarse adjustment, and then your finer adjustments are going to be with your either your idler adjuster or your Lovejoy. And on the seal unit, you're going to have a lot of similarities. This one does have the main drive on the control side. That's a little bit different. It still uses a slide on the motor. This is the end of the motor shaft to adjust the chain. There are no idlers on this one. This is a fairly short chain. It also uses the same board. It's a KBIC, and if you look real close at the video, you're going to find out this one looks a little bit different. The only difference is the one on the Orca has what they call a barrier board on top of it, and that's just a place to make connections and attach fuses. So again, if you do need to check your motor speed, right through this hole is where the motor connects, and you can check it right here. On the seal, if you look at the motor, it's going to say 180 volts is the maximum. So at top speed, you're going to have 180 instead of 90 like on the Orca. But it works the same way when you either step on the foot pedal or hit the go switch. You apply line voltage to the speed control board, which applies voltage to the motor based on what speed you've got it set at. Now, one troubleshooting tip I will give you: if your machine will move with the foot pedal but it won't move with the control panel switch, chances are you've got something going on with one of your safeties. A lot of times on these machines, the foot pedal overrides the safety. This one is the Falcon 60 Plus, and you're going to see it uses the same board as the Orca, and this one has the barrier board on it. You can see the two fuses there, and it just makes its connections on this terminal block instead of plugging directly into the board. So two things before we wrap up on the drive system. Number one is lubrication. So we know that grease and oil is used to lubricate these machines, and you're going to see grease fittings here and there on the unit. It has been my finding, in my opinion, that you very rarely need to add grease to these machines. Those fittings are mainly on there for when the machine is manufactured and all those parts are dry. The other thing is, for lubricating chains, you never want to use grease. You only want to use oil. You can use WD-40 or lightweight machine oil, but never use grease on the chain. The other thing is, sometimes you're going to see a sensor that's positioned right near the main drive on there, and what that's on there for is to give feedback to a counter or a speed display that's on the unit. This one doesn't have one. So I wanted to show you inside the Seal 62 Pro. On this unit, they decided that they would put the speed control along with the operator controls. So your speed control is built into this one board that also has the control panel on it, but you can still check your voltages at the motor, and as I say, if you got to go deeper than that, you're going to need to get a hold of a wiring diagram. Every once in a while you'll find a wiring diagram inside the side panel, but you're not always going to be that lucky.